And so our final presenter tonight is Dr. Robert Craigen. Dr. Craigen is a math professor at the University of Manitoba. He's been awarded the Kirkman Medal for Early Career Research in Combinatorics. How about that? If it's that hard to pronounce, it must be really hard to do. In 1994, and a Manitoba Provincial Mathematics Curriculum Teaching Award in 2002. He has led numerous workshops and symposiums on math curriculum and teaching, and he is the co-founder of Wise Math, Western Initiative in Strengthening Math Education. And I just wanted to point out to you, ladies and gentlemen, that Dr. Craigen has come here from Winnipeg. These people have come a long way. This is an important subject to them. So important that they are willing to take their time and come to a different province, in a different part of the country, just to help us to get through this. Dr. Craigen was part of trying to defeat this Discovery Learning program in Manitoba, and finally after Manitoba's math scores dropped right out of existence, they were able to, but a generation, entire decade of students lost out on this. But we're so pleased for these people that they will come here and help us out in Alberta. Where we want to say, look at what has happened, look at the proof, as Dr. Nung has said to us. Where are the studies? Where are the actual proof that these sorts of concepts have been successful anywhere in the world? So Dr. Craigen has come to us from Manitoba, but I'm particularly proud that I share one of Dr. Craigen's most impressive and serious credentials as an accomplished internet social network pain in the butt, meddler, and bull in the china shop. Dr. Craigen's topic tonight is fixing math education in Alberta and Canada. Please help me welcome Dr. Robert Craigen, PhD.
Thank you for that generous introduction. I don't know how to follow these three speakers. All three of them really said it. We could have stopped after any one of them and said we're done for the year. We've said what needs to be said. But I'm going to try to say a lot more. I'm going to give you a bigger picture of what's going on in Canada and what has been happening, and some of the larger ideas behind this business in math education, and what Wise Math is. You see here that or you don't see yet, but now you see, I am associated with a group called Wise Math. I'm a co-founder of this organization. The WISE is an acronym. It stands for Western Initiative for Strengthening Education in Mathematics. And my co-founder is Dr. Anastaki from the University of Winnipeg, and I'll be mentioning her a few times over my talk. You can find us at that address, wisemath.org, and we have a Facebook page as well. And that's my contact information. You can get that from me later so that I can get off of this slide. A lot of people want to know, why do mathematicians care about math education? And Vladimir has done a good job of saying that, so I'll just go very quickly through this, as I will through many of my slides. If you feel flooded with information, don't try to take notes. I tell that to my students in certain lessons, and this is one of those lessons. You can have my slides later. I teach mathematics. I teach graduates of this K-12 education, so that's one reason that I care about education in the younger grades. I have children and grandchildren who have been and will be affected by public education. I helped establish something called Archimedes Math School with Anastaki. It's a separate initiative. This teaches mathematics to local kids in the city. Finally, as a mathematician, I know that mathematics is relentlessly hierarchical, and Vladimir has already talked a little bit about this. Calculus depends on algebra. Algebra depends on arithmetic. And automatic recall of math facts underlies arithmetic and predicts high school performance. So numerous results, in particular one just last year, Dr. Ansari from the University of Western Ontario established this with MRI machines, if you can believe it. There's a medical mathematics connection right there, looking at people's brains. And fluency with fractions and division. At the end of elementary school, uniquely predicts performance later. So what those kids are doing in grade 7 makes a difference at the end of grade 12. And it is our best predictor of how they're going to be doing, how they do with fractions and with division. So we should pay attention to those things, and as a university mathematics professor, I do. Now, some of you have seen the new C.D. Howe report or have heard of it. This was written by my associate, Dr. Stocky. It is about math education in Canada and says many of the things we are saying tonight. You should read the report if you care about policy, because it's full of stuff, lots more than we can say here tonight. So here's the report, What to Do About Canada's Declining Math Scores. And she makes 3 key recommendations, and I thought I would start with those. First one has to do with pedagogy, what she calls the 80-20 rule. Believe me, on social networks, there's a big buzz about this, because she says 80% of teaching time, this is a rule of thumb, by the way, 80% of teaching time should be devoted to direct instruction over discovery methods. So the first thing you should note is we're not saying don't do any discovery. What we're saying is put the emphasis where it ought to be. It's intended to guide our notion of balance and emphasize what's critical for success. The true balance is not always necessary halfway between 2 extremes. Okay? It generally is not the case that that's where balance lies. You have to know what's important. This is not intended as a hard and fast rule. It would be impossible to enforce such a thing anyway. Too often, when people say they're for balance, that's a verbal cloak for something that's actually quite unbalanced. And so we thought it was really important to lay it out what we really mean by balance. Second one has to do with the curriculum. Focus on content and mathematical considerations. The provincial math curricula should be rewritten to remove ineffective pedagogical directives, and ministry people are always coming to us in Manitoba saying, where are these directives you're talking about? Well, often they're just sort of written in. You can't really assess something, or you can't use an achievement indicator that's written in the curriculum unless you've taught in a particular way. It's there by implication that it's sort of, you know, these little coercive things within the curriculum. I was on the steering committee for our province for 5 years. I heard the mathematics consultants, the people who were involved in designing the curriculum, saying, oh, last time we tried this, the teachers didn't get on board, but we've made sure they're going to do it now. They can't really. It's there by design. Okay, the WNCP curriculum, you're going to hear me saying that a lot. This was led by Alberta, but it is in use across Western Canada. All 4 Western provinces, the Maritime provinces, have adopted or adapted it. It's full of pedagogical hooks, as I said. Multiple methods and spiral structure. They crowd out mastery. And the spiral structure, you'll hear me talk about this, this just means you come back and revisit topics and never really assume that you've finished with them. Critical material, as Vladimir has said, is de-emphasized. When you have all that multiple methods and multiple representations and discovery approaches, you find that the topics are crowded out. There's just no time to teach everything. We want to see international benchmarking, pick the best school systems in the world and compare to them line by line, and see how we're doing against those. We want the design to respect properly controlled studies, as Stuart has said. For example, there should be memorization of math facts in early years. There should be mastery of fractions by the end of middle school. And the third recommendation has to do with teacher training. We want to properly ground all teachers, not just the high school math teachers, in appropriate math content. Future early and middle years math teachers should be required to complete a minimum of 6 credit hours of math content courses. And then later they should be able to pass a simple exam on that material that they'll be teaching for their licensure exam, or for their credential. Teaching is a profession. We have great respect for teachers, and we want to see it treated like a profession. And so this is just basic common sense. We want them to demonstrate fluency in the topics they're going to be teaching. You can't teach what you do not know. In most of Canada, education is the only professional program that is available to graduates of high school that don't have academic stream grade 12. Okay? This is a magnet for students who are weak in math saying, gee, I want to be a professional, what can I do? They go into early and middle years teaching. So we get early and middle years teachers with low confidence themselves in mathematics, and the results are predictable. The top systems, Quebec, Finland, Singapore, Japan, Korea, and some others, they require even higher early and middle years credentials than we're talking about here, considerably higher. Quebec, for one, much higher credentials for all teachers than we're asking for. Manitoba, and this is actually without our direct input. It turns out Manitoba has decided to add a 6 credit hour requirement for all teachers in math content starting in this fall. Okay, so let's look at some of the things that are happening to our students. The PISA results. I say keep your eye on the trend, not on the rank. We say, you know, things are really declining, they're looking really bad, and somebody comes out and say, yes, but we're one of the top jurisdictions in the world, one of the top school systems in the world. Keep your eye on the trend. Okay, 2003 to 2012, those are important years for PISA. The international assessment called PISA, run by the OECD, because those are the years in which they concentrated on math. Those were the primary domains under assessment. All provinces declined over that period. Quebec and Saskatchewan only insignificantly, but they did decline a little bit themselves. The steepest drops were Manitoba, where I'm from, and Alberta, where some of you are from. 36 points for us, 32 points for you. That is huge, especially over such a short time period, 9 years. You want to compare internationally to what people think of this kind of decline. Look at Sweden. Sweden dropped 30 points. The OECD prepared a long document, 200-page document, talking about the Sweden case and decrying it and saying that things have to change in Sweden because this is too dramatic. Once seen by many as a model for high-quality education, there's been a stark decline, there's disappointing findings, and the factors that are identified are a decline in the rigor of teacher education programs, lack of coherence in the curriculum, and lack of coherence in pedagogy and in the learning goals. Does any of this sound familiar? Canadian average decline, by the way, was 14 points. We'll show you a little bit more about that in a minute. Canada is in the top 15. Well, good for us. There's a lot of countries in the world. Top 15 is pretty good, right? But we're far behind the leaders. We lead a mediocre pack. Have you ever watched bicycle racing? You know what I mean between the pack and the leaders? There's a big gap there, isn't there? Guess which one we're in? We're about 100 points behind the leader, Shanghai, on PISA. That's a full standard deviation. Those of you who know a bit of statistics, you know that's a pretty big gap in a crowd that has a pretty well-defined bell curve. Manitoba is scoring below the international average, and I don't think I need to add, that is a very low bar. Canada and Alberta, the rest of Canada and Alberta are approaching that bar from above. Okay, but even more important or more interesting, more telling than those numbers, the absolute averages, are the proficiency levels. PISA has 6 proficiency levels, 1, 2, 3, 4, 5, 6. 1 is bad, 6 is good. Okay, let's look at proficiency level 2, and I'll tell you why in a minute. That is a significant level. Canada dropped. 10.1% of our students were below level 2 in 2003. In 2012, 13.8. Guess what? That cohort is growing. Let's look at levels 5 and 6. Canada, 14.1% were in the top 2 levels. in 2003. In 2012, 9.4, a drop of 4.7. Now let's look at Manitoba. Our province was at 10.9% in that lowest cohort, below level 2, grew to 21.2, 10.3 increase. That's 20% of our population is below level 2. Almost 20% was above level 2, 18.9% in 2003, 2010, 10.3, a drop of 8.6. Now let's look at Alberta. 7.4% were below level 2. 9 years later, 15.1%, an increase of 7.8. Okay, 26.8% at levels 5 and 6, dropped to 16.9. Those are your top students. And just a note here for the statisticians in the crowd, the standard standard error in these numbers is about 2. So all of these numbers, every single one of these numbers is very significant, statistically significant. Okay, so what's this level 2? The OECD describes it as the baseline for participation in a modern society. So, in other words, below that level, you are functionally innumerate. Okay? Manitoba and Alberta functional innumeracy has doubled in 9 years. Level 5 is where you start looking at what we call STEM leaders. That's science, technology, engineering, and mathematics. These are the leaders of tomorrow, the people who are in the so-called information technology and leading the 21st century. If you want to talk about 21st century skills, that's level 5 and up. The Alberta STEM leaders, therefore, have declined by over 37% in that time. That's the direction we're going. Keep your eye on the trend. Okay, I'm just going to briefly look, this one slide, at the PCAP assessment. This is just like PISA, except it's just for Canada. These are the various provinces. And I want to just make a brief remark here. First of all, the red bar is the error bars for Canada, so you know Canada's score is within that red error bar. The tall bar there you see is Quebec. The next one is Ontario. Those are the only provinces above average. They're large provinces, so they define what the average is largely. And you see there's Alberta, the third one, the second from the left. That is the third province in Canada. So you'll hear people say, well, we're the third highest province in Canada. And so that's great, yes, but we're below average. And Manitoba is the very shortest one right there. And I want to tell two stories about this. One story is about Alberta, not very long ago, led by people like Stewart and others. Alberta was the top bar. Alberta was the leader of Canada and had been for many, many years, until about the time we started implementing the WNCP curriculum, where Alberta is the leader. The other story I want to tell you is Manitoba. We have, in fact, declined quite a bit. And Prince Edward Island, you'll see it's second from the right there. It's doing pretty good. It's just behind Alberta. Guess what? Prince Edward Island, in the previous PCAP assessment, was the worst province in this measure. So it's kind of interesting. We should be all going over to Prince Edward Island and asking them what they did. Well, I'll tell you one thing I know they did. We don't know very much about them. They instituted standardized testing across several different grades 5 years ago. Well, you might say, well, that shouldn't have any effect. Well, another thing, this is just an observation. When Anna wrote her report, these reports, by the way, CD Howe is the most rigorous refereeing system I've ever seen. First of all, the editorial board looks at your paper. Then it goes through 2 levels of refereeing and a committee of referees. A large committee of referees in each of those levels sends in comments. And then after it's passed through those 2 levels of refereeing, the report goes out to every Ministry of Education for comment. And the comments we got back from Prince Edward Island really stood out. They said, essentially, this is exactly what we need. The recommendations you're making are precisely what Canada needs. So, before I even go and talk to them, I will actually be in Prince Edward Island in a few days. Before I go to talk to them, I think I already know sort of what's going on there, just from that. Okay, the Western and Northern Protocol, here's a bit of history. The first common curriculum framework was introduced in 1995, so that was some time ago. The second version was released in 2006, and the protocol covers the provinces in the West, and then later the Maritimes bought into it. 8 out of 10 provinces are now under this same curriculum. BC has pulled out, although they're still using it. So what are the changes that we consider problems? Standard algorithms are eliminated. We've returned them in 2003 in Manitoba. They're still absent in Alberta, although they are optional, but of course they've always been optional. Math fact memorization was eliminated in 2 provinces. This is back, Manitoba, and now a year later, Alberta has at least got the word recall when it talks about multiplication in grade 5. Instructional resources that accompany the curriculum support multiple and ad hoc methods. There's no central schema or schemata. What is a schema? It is a coherent, unified way of looking at something. So when a person learns through WNCP and then you give them 5 digits to add, 2 5-digit numbers to add, what do they say? Well, they say, well, which one of the classes does this fall into? Because they've taught, if it looks like this, you do this, and if it looks like that, you do that. And there is no single unifying way to look at it. When a mathematician or somebody who learned more than 20 years ago looks at that sum, they say, oh, it's a cascade of single-digit additions with a carry, possibly. If you give them 30 or 40 digits to add, it's the same thing. Why? Because they have a unifying schema, a single way of looking at it that tells them what addition is. A person who has a pocket full of ad hoc techniques doesn't even know what addition is. They have a hard time with that. They may sort of conceptually understand it, but they don't have a unifying way to look at it. The early and middle years knowledge preparation, as I said, is weak. And problems with Pro-D, that it is pushing these techniques on teachers that we don't consider particularly well advised. The spiral structure is evident throughout the curriculum. Some elementary topics are moved to much later. Ontario, I haven't mentioned them yet, they adopted a similar curriculum, but they opted not to be in the WNCP curriculum because they have a lot of their own experts and they just had some differing opinions, and so they went their own way. But it's very similar. Compare Quebec. Quebec has a new curriculum, and I need to tell you one more story about Quebec. 15 years ago, Quebec was in about the same place we are. They were the first province to introduce these methods, and I noted when Nung said, when in medicine they find out that a drug that everybody is using is harmful, it's pulled from the market. That's what Quebec did. They did a study, they looked at the results of their discovery-based curriculum, and they drew back from it. They have moved in the opposite direction. Their new curriculum, they call it progression of learning. It is more ambitious in the arithmetical sequence. The teacher is now explicitly made responsible for learning, directly responsible for learning. There's a clear point of closure on every topic, contra the spiral curriculum. They've moved away from discovery and inquiry. There's more emphasis on mastery of specific skills, and they have the highest standards for math teacher content knowledge coming into the profession of teaching by a long shot. The curricula are were varied across Canada. If you go back prior to 1995, here we're going backwards in history. In 1978, that curriculum was used until 1995, and I'm talking here about Manitoba, and I will a little bit because that's where we have direct access to stuff. The changes we see from 1978 to 1995 were dramatic. I put that in bold because it is truly dramatic. Fraction arithmetic, for example, moves from grades 4 and 5 into grades 7 and 8. It's time-consuming, multiple approaches to everything. Calculator use pervades, and it supplants paper and pencil proficiency And in the new one in 2006, they even directly say to start getting rid of the paper and pencil stuff. Emphasize that less and less. The educational philosophy is constructivism. That's essentially what's at the heart of everything, which is another word for indirect instruction and discovery learning. Experiential learning. These are some other phrases that are used. Problem solving. I have to be careful here because problem solving is an important part of mathematics, but meaning problem solving as an instructional technique to sort of teach children something that they don't know. And cognitive-based instruction, you see these phrases, child-centered, oops, I think I missed one there. Yeah, the 21st century curriculum. Okay, so here's a sample grade 3 provincial exam. You can't read it, but what I see is 3-digit sums and little boxes for students to fill in the answer. And here there's a sum of 3 3-digit numbers. This is in grade 3. Multiplication of 1 digit by 3, 1 digit by 2, and so on. A simple word problem, fairly simple word problem, 36 chairs. Each row has 9 chairs. How many rows are there? It's a division problem. And so if we jump ahead to 1999, here's what a comparable problem from the grade 3 provincial exam after WNCP. There's a bar chart, as you see, in grade 3. You want to order several kinds of cookies from this year's sale. Use the information in the graph to help you decide. Which kind of cookies will you order? Explain. And our choices, are, I can't even read them, chocolate, oatmeal, and a couple of others. Okay, so that's your math question in grade 3. Okay, the characteristics of WNCP math. It's claimed that this will teach deep understanding, 21st century skills. To a mathematician's ear, deep understanding sounds great. But there's a lot of undefined terms. Even the term understanding is undefined. The stuff that they're teaching is very hard to measure. And observationally, it is building a house without a foundation. Understanding without knowing facts, that's been mentioned already. The outcomes consisting not of usable skills, but of classroom techniques. For example, learning how to multiply 5 times 6, you draw a little rectangle, and there's the boxes, you can count the boxes, there's 30 of them. Okay, that is a technique in the classroom to help somebody sort of conceptually know what's going on. That is not a suitable learning outcome. Okay, it's a way to teach something. Okay, it's confusing pedagogy with outcomes. Standard algorithms are downplayed and or absent. Times table memorization. And again, these are returned now in Manitoba, but not in some of the other provinces. This one you can't read at all. This is straight out of the changes, the 2014 changes to the Alberta curriculum. I just want to make a couple of points about it. We're told math facts are in the curriculum. Memorization of math facts are in the curriculum. And in fact, it does say here, understand, recall, and apply multiplication math facts up to 9 by 9. That's in the little box there. The 3 highlighted yellow phrases are the changes, and they basically add the word recall into the middle of sentences. This is in grade 5. We're talking about memorizing times tables up to 9 by 9. But look at all the other stuff that's in there. What do you see there? Well, you see things like they should also know how to multiply by doubling and by counting on. Counting on is, I want to do 5 times 6, but I know 5 times 5. So I go 5 times 5, and then I need 5 more. So I go 26, 27, 28, 29, 30. Okay, that's counting on. It's one of the strategies here. These are ad hoc strategies for performing that. You know what I see? I see workarounds. I see, what is a workaround? It's something you learn to do because you haven't learned something else. It's to compensate for not having memorized. Okay, so this is what's been in our curriculum for quite some time now, and we've added the word recall into the middle of that mix. Okay? Knowing a workaround, by the way, is not understanding. We're continually pointed to this saying, look, we're teaching them how to understand this. They know how to double this in order to do the multiplication, you know, double and then they do accounting on things. Show how much they understand. Actually, that's not the same thing as understanding. That's a workaround. Miscellaneous strategies, it's a mixed bag approach. As I said, there's no schema. There's obsession with the details of single-digit arithmetic for 5 years in this curriculum. That is far too long to be thinking about the mechanics of single-digit arithmetic. Okay, it should be, yes, there should be a point where students are looking at that and going the counting on and everything. That should happen very quickly, and they should have it memorized and get on with their lives. The best education systems require mastery up to 9 by 9 in grade 3 and 4, and some go well beyond that, 9 by 9. But 9 by 9 is the necessary ones in order to do fluent arithmetic. Okay, here's something else from the 1978 curriculum documents. This is from Manitoba again. We go into the archives and we find these things. And this is just, we have lots of these, but this is grade 3 multiplication. Increase the proficiency with addition and subtraction facts up to 20, and multiplication and division facts up to 40. Grade 3. Grade 4 multiplication, recall with proficiency all the basic facts for addition, subtraction, multiplication, and division. This is a closure statement. It's saying the students have to have this and it's done. And we can assume it in future years, so they know this stuff. Okay, here are some current strategies. This is a typical take-home sheet that's coming home to parents across Western Canada. And different ways to add 36 plus 17, 78 plus 23, to multiply 23 times 14 in the bottom left, and a little subtraction one. I like the little exploding stars there. Here's division from the most popular WNCP text, Math Makes Sense, or most popular within the schools, I should say. This hasn't communicated yet to some of the parents, or most of the parents that we talk to. How to divide, what you do is you take a bunch of blocks and you divide them up in a certain way, and we can divide 728 by 5 with this exhausting procedure using blocks or drawing blocks, and imagine you're playing with actual blocks. And this is modeling backwards. Vladimir mentioned modeling. Mathematics models real things. This is backwards modeling. You have mathematics and you're modeling it with blocks. Okay? But it's also replacing a pedagogical replacing an outcome with a pedagogical technique. The moment your bank teller does this, get a new bank. Okay? If they're adding up your checks and they pull out blocks, forget it. This is not a learning outcome. It is a way maybe to help somebody understand something, to get over a mental block. Another line we got when we started doing this stuff is, well, you don't actually mention the standard algorithms, it's just assumed that they're there. And we're told this a lot with the Alberta, it's assumed that they're there. In fact, the changes they've added to the curriculum, you know what the document is called? Clarification. Clarifications. It's like, well, we really meant that all along. So in 1978, here's what the Manitoba curriculum said. Demonstrate the use of standard algorithms, using digits up to a combined total of 8. 4 digits by 4 digits, 2 digits by 2 digits, etc. And then it says, you can also get them to try some non-standard methods. And down here at the bottom, it's a footnote. It says, non-standard algorithms often provide children with motivating activities, particularly when they're related to history. There are a number of books on now available to provide teachers with backgrounds, lattice multiplication, Napier's bones, etc., etc. But up above, you see exemplars in the curriculum showing actual standard algorithms. It's pretty clear what is intended. Okay, outcomes are much later than other jurisdictions. It underestimates kids. Single-digit arithmetic till the end of grade 5. Versus other jurisdictions that have strong curricula. US, Singapore, and Finland have fraction arithmetic in grades 4 and 5. We have it in 7 and 8. there's a lot of language about modeling mathematics and arithmetic. Again, more of the backwards modeling. And this is a good example. This is intended for grade 9, and I'll show you a picture of it. You might, yeah, okay, it shows up better there than on the screen. This is grade 9 arithmetic. From a distance, it doesn't, what does it look like? What grade level? 2, 3? Okay, what you see is these represent polynomials, you see. Okay, it's, and I could go on about it, but this is a perfect example of this backwards modeling that takes people away from abstraction. You see something abstract, what do? The instinctual relationship is let's make something concrete out of it. So addition and subtraction appears in grade 7, multiplication and division of fractions in grade 8. The 1978 curriculum has this all in grade 5. US, Singapore, and Finland, top jurisdictions. US is not a top jurisdiction, but it has introduced a new curriculum that is internationally benchmarked, grades 4 and 5. A meta-study shows the importance of fractions. Analyses of large representative longitudinal sets, that means it follows kids through their careers, from the United States and the United Kingdom show that their knowledge of fractions and of division uniquely predicts those students' success later in high school, 5 or 6 years later. Okay, so this is not a problem to do with your grade 7 math. It is something that affects their entire history later. And here, I wanted to get to this. I don't know how far I am in my thing. I guess we're getting close to the end here, right? Okay, so yeah. Okay, one last thing. I have to do this, and then we can get to questions. 2 Tim's assessment questions, and whether or not you can see them, I'm going to read them off. The first one says, which method will find 1/3 minus 1/4? It's fractions. And you see 1 minus 1 over 4 minus 3, Vladimir mentioned this approach. 1 over 4 minus 3, and then the last one is 4 minus 3 over 3 times 4. Now if you were going to do this, if you were going to guess at this, there's 4 options. Your likelihood of being right is 25%. So over a large population, if everybody's guessing, you'll see 25% correct answers. If you look down here, you see Korea is getting about 86% right. The top jurisdictions are getting up in the 70s and 80s. The Canadian, not so good. The Alberta score was 28. Almost undecipherably different from random guessing on that outcome. This is in grade 8, a year after they supposedly learned this in the curriculum. The second one is about multiplication. It's about understanding how multiplication works with non-integer numbers. And here we see a number line between 0 and 1 and 2. And then you see 2 dark dots, that's P and Q. And you're asked, where does the product of those 2 numbers lie? Now P and Q are both less than 1, and you should both know that when you multiply by a number that's less than 1, it makes the result smaller. Okay, so you should know immediately that the correct answer is to the left of both of those numbers, and that would be A. But there's 3 other choices there. And again, this was more poorly done, not surprising. It's a cognitive outcome. It requires you to understand something rather than to just produce a number. The top jurisdictions were getting only just under 50% on this one. But Alberta managed to get 24, which is worse than random guessing. And I'm going to stop there, although I have a lot more I'd like to cover, but we'll open it to questions.